You're welcome to Science Spectrum with Don. This is the second aspect of the first lectures. And of course, in today's class, I will proceed with the aspects or the realms of physics. The aspects of the realms of physics. Simply put, you could call it the branches of physics, as you like it, of physics. Alright. Now, having talked about from the previous class that physics has specialized fields like MRI, CT scan, radiation therapy, the heart catheterization, and of course the list could go on and on. There are aspects of branches of physics. Now, physics has basically two aspects. All physics from the 17th century up until the 19th century is one aspect of physics. We call that classical physics. And of course, all physics that goes beyond the 19th century and beyond, we call that modern physics. And of course, you could get some divisions under this aspect. So, the first aspect of physics, we call that classical physics. Classical physics. Classical physics. What's classical physics? It's just a branch of physics that stretches from the 17th to the 19th century. The 19th century. And of course, the other realm of physics is called modern physics. Modern physics. Modern physics actually evolved due to the fact that some aspects of classical physics failed. So what modern physics came to do was just to augment it. Now, modern physics is all physics that goes beyond the 19th century and beyond. Simply put, up until this moment, century and beyond. So these are the two aspects of physics. However, there are some groups in classical physics, or we call them subdivisions. Alright, so let's get started. Now, in classical physics, which is the first aspect of physics, classical physics, all physics from the 17th century up until the 19th century, you have the first subdivision here. You have classical mechanics. Classical mechanics. Classical mechanics. Classical mechanics is simply an aspect of physics that describes motion, changes in motion, and of course, the force that would cause or affect changes in motion. Now, in classical physics, or in classical mechanics, there are two categories there. You have kinematics. You could think of it as coined from the word cinema, just motion pictures. When you deal with motion, changes in motion, and you don't really care about what causes the motion, that's kinematics. So we have kinematics. There is kinematics in classical mechanics. This deals with just describing motion, regardless of the force that causes the motion. And of course, we also have dynamics. Dynamics deals with describing motion, and of course, the forces with reference to the forces that could cause the motion or changes in the motion. Alright, this is the first aspect of classical physics. Then we have optics. Optics is simply a branch of physics that deals with the study of light and vision. Just think about it. How would the world be if we hadn't light? Or even if there was light and you have no vision? Just think about it. Alright, we have the third one. That's thermodynamics. Thermodynamics. This aspect of physics is just a collective term that deals with concepts of heat, temperature, energy, work, and power. So this is just a collective term, a collective concept for heat, energy, temperature, something that indicates if a body has heat or not, energy, then we have power. Alright, then we have the fourth one. That's an aspect of physics that deals, just a collective term that deals with both electric and magnetic phenomena. We call that electromagnetism. Magnetism. So it's just a collective term that deals with, that treats, so to speak, that treats both electrical and magnetic phenomena. Alright. Having talked about this, you have other aspects of classical physics. That's subdivisions there. You have fluid dynamics. You have fluid dynamics. There is fluid dynamics. You have elasticity. Fluid dynamics. You have elasticity. You have waves and vibrations. Of course, these are aspects of physics that makes our world even more beautiful and fascinating. And the fifth one, we have fluid dynamics, fluids. The sixth one, we have waves and vibrations. Waves and vibrations. Waves and vibrations. And of course, the list could go just on and on and on. You have elasticity, where you have your Hooke's law, the Young's modulus and Hooke modulus and co. So we call that aspect elasticity. Elasticity. And of course, the list could go on and on. So in classical physics, I just mentioned a few aspects to us. Now we move on to the second aspect of physics, which is called modern physics. Modern physics came to augment or to make up for the lapses in classical physics. So the first aspect you will think in classical physics is that in modern physics is called relativity. Relativity. This was a theory that was proposed by the great Albert Einstein. So what this theory did was it just had to make up for the shortcomings of Newton's laws of motion, because when you compare the speed of objects to the speed of light, you find out that Newtonian mechanics is no longer valid anymore. Rather, we could use Albert Einstein's special theory of relativity. We also have quantum mechanics. This aspect of physics is simply the workings of your players, that's your DVD players. It's quantum mechanics. So most electronics you see, the underlying principle behind its working, aside from electromagnetism, is simply quantum physics. So we have quantum physics. You have the study of the evolving universe, that's cosmology. Cosmology, cosmology, cosmology. You could also have nuclear physics. Nuclear physics, nuclear physics. When you delve into, or you probe into the nucleus of an atom, you find most interesting things there. Nuclear physics. And of course, the list will go on and on. You also have plasma physics. You have plasma physics. You have quantum electrodynamics, and of course, the list could go on and on and on. So these are basically the aspects of physics. Now, I would love now to talk about briefly the relation between physics and engineering. Now, there is a parallel between physics and all engineering. Now, who is a physicist? A physicist is simply a person or persons that explains the underlying principle or the workings behind physical realities you see all around you. And of course, what do engineers do? Engineers make use of these principles purposefully. They use them in designing things we call utilities that makes our world better. So we'll talk about the relation between physics and engineering. So who is a physicist? A physicist explains, or as you would simply put, describes the principles. And when I mean principles, I'm talking about the how and the why things happen. So that's the how and why. Okay? The principles of physical realities. Physical realities here could be matter or natural phenomena. Like I said earlier on, it could be any name. Think about the stars, the planets. It could be fact, process, or an occurrence. Or physical realities or matter. And of course, what do engineers do? They learn the how and the why of physical realities. That's the principles of physics. They use that in engineers, make use of science, make use of the principles of physics purposefully. This is simply who the engineers are. They really don't know the how and the why But when you tell them the how and the why, that's the physics job. They get to do or make things that makes our life beautiful. So you could think of interplanetary aircrafts. You could think of vehicles, your LCD, your flat screen TV. You just name it. So the principles behind those things you see is given by physicists. The engineers make use of the principles of physics purposefully to make or produce things. We call them utilities. All right, having said this, if you're new to this channel, please you may want to like, share, and subscribe for more content. And it may interest you to know that this course would go beyond course 187. There are other course codes, 188, 189. I will be detailed in chemistry, mathematics, biology, geography, and of course, and many more. All right, in our subsequent bulletin, I will talk about how we describe the world around us. Of course, we use physical quantities to describe the world around us. All right, thank you for tuning in. See you in our subsequent bulletin. Thank you.